Let's get started. So, hello everyone. We're going to talk about how we delivered millions of notifications within a few seconds during Super Bowl. I'm Jen, and let's just get started. Actually, before we do, a quick show of hands. How many of you know Duolingo? Wow, that's actually quite a lot. I wasn't expecting this much. We did the same back in London, and I don't think it was that impressive. So I guess still a brief introduction of ourselves if you don't know Duolingo. Duolingo is the most popular language learning platform, and we have the most downloaded language learning app worldwide. And our mission is to develop the best education in the world and make it universally available. So what do we have? We currently have 31.4 million DAU, which is daily active users. And we have over 100 courses offered in 40 plus languages. On top of that, we also have a very unhinged social presence. So you may know us from a lot of things, and I assume internet memes is one of them. You may have heard of Spanish or Vanish, some other stuff that I won't name. But also, our marketing team is really hard at work. So you may have seen some of the pretty wild TikToks or memes that revolves around Duo or our employees. That is really our marketing team hard at work. And let's switch gears a little bit and look at this number, 123.4 million. Does anyone have a guess of what this number could be? Notification, we would like it to be that way, but not yet. But that was a good guess. That's actually the number of viewers of last Super Bowl. So this year, the Super Bowl game between Kansas City Chiefs and San Francisco 49ers brought an average of 123.4 million viewers. And that is the highest number of people watching the same broadcast in the history. So since we're in the US, and I don't really have to tell you what Super Bowl is, I assume. So we'll just skip over this. But if you ask ChatGPT to create an image of a typical Super Bowl ad, it kind of looks like this. Basically what you would expect from a ChatGPT image. It's kind of all over the place. It has cars, angels, neon signs, everything. But why are we really talking about this? This is because everything was fine for us engineers at Duolingo for a while. Until one day, we heard that Duolingo will run its first Super Bowl ad as it expands beyond TikTok. Our chief marketing officer expects the brand to be even more unhinged in 2024. Then we saw some design docs that revolves around Duo's butt. Okay. So we know what's coming here, so I might need some audio help to play this, hopefully. All right, so what really dawned on us was that we are buying a Super Bowl ad, and this is a 5-second ad that was played during this year's Super Bowl, but at the time we know that it has something to do with Duo's butt. Oh, actually, I forgot. There's one last thing. The marketing team asked us to do a push notification at the same time. So what could possibly go wrong? All right, so let's give you an overview of today's presentation. We'll take you on a deep dive into the superb OWL service, which we named conveniently after the Super Bowl. First section, we'll be talking about how we dissect this impossible task. Then we'll talk about how we cope with the changing requirements, followed by talking about the architecture deep dive into how exactly the service works. And last but not least, we will talk about what we learned and what we would have done differently. So a fair warning of this presentation. This is not really a presentation on you should be doing this, but instead of this is what we did. And I hope you could perhaps learn something from our journey. So let's start out with a dissection of an impossible task. when I use the word impossible, it may sound kind of strong to you. I mean, it's just sending notification, right? Well, when the marketing team came to us, they asked us, well, we want you to send millions of notifications in a few seconds. And can you do it? And we were like, hold on, let's do some research. And we did some research, and we came back to them and said, well, I don't think we can do that. And then the next thing you heard was that them telling us, well, we already paid for the ad. So actually at that moment, it wasn't really up to us. We have to do it. So they told us that they want to send 4 million notifications within 5 seconds. When they first came to us, we were actually a little nervous because here you see how fast our notification typically goes out. It's at a rate of 10,000 notifications per second. And I mean, if you do the math, that's actually a lot of notifications per day. But what they're asking is to send notifications at 80 times faster speed. And if you're a site reliability engineer or you work in the back end, there might be already alarms that are going off. Yeah, so this is what I'm talking about. Back in 2022, Coinbase launched its bouncing QR code-like campaign during Super Bowl, and it was so popular that it crashed their site. We probably don't want to do the same. And on top of that, we also discovered an issue with our Android app so that, well, when we send out a notification to the Android app, it sends a request right back to the backend. Well, this sounds a little similar to DDoSing ourselves. So if you want to send like 5 million, 4 million notifications within a few seconds, you probably want to avoid doing that. So in theory, leadership would just came to us, well, you should just ship it. Actually, ship it used to be, or I don't actually know if it's still like a principle at Duolingo, but in practice, this is kind of a complicated problem because here you see, we want to build a system to send notification fast. We also want to make sure that we do not DDoS ourselves. We also want to handle the organic traffic because people actually click on those notifications and come back to the app to practice learning new languages. And our solution is basically somewhere in between those three problems. And to make matters worse, we have people coming to us from different perspectives, product managers or other engineers. They come to us with suggestions or inquiries. Can we add an icon to the notification? Can we send to more cities? Can you localize the push into different languages? Can we use a vendor for this? All of these questions. So at this point, you might be imagining there's like your favorite superhero from Marvel or DC to come and save the day. I mean, in this case, we would probably call it the coding man or something. There's no coding man in real life. So what we did was just very simple. We divided and conquered the task. I was in charge of building the system to send notification fast. Two of my wonderful colleagues, Luis and Milo, they're respectively in charge of making sure that we're not DDoSing ourselves and making sure that we can handle the organic traffic. So let's move on to the next section, and I'll talk about how we cope with the changing requirements. On the first day of the project, my technical program manager, Paul, came to me and asked me, well, can you give me a timeline on this project? And at the time, I wasn't really a senior engineer, and I said, well, sure, but where do I even start? Because it's such a complicated project. And all we knew was from August 2023, we know we want to send 4 million notifications in less than 5 seconds. And Super Bowl happens the next year on February 11th, and they're not going to move that date for us. How do we account for all these uncertainties in between? And as you may know, to make matters worse, requirements are always changing. People are suggesting all sorts of things to do. You should do this. You should design this system in one way than the other. Well, to give you an example, this is a slide that I showed you before. I said they came to us saying, we want to send 4 million notifications within 5 seconds. Well, that was actually a lie. That actually changed, because when they first came to us, they told us that they want to send notifications to 3 markets with 2.6 million notifications in total, and they want to send all of it within 8 seconds. Well, a few days later, they changed their mind. They were like, how about we round up to 3 million notifications? And we want to send all that in 5 seconds. And a few months has gone by. They came to us. They told us, well, we actually closed a new deal, and we now have the ability to show the ad in 7 markets. Woohoo, wonderful. But that also means we want you to send to 4 million users. And because we're in the United States and people have a lot of digital devices, and potentially we want to send to 6 million plus devices, which is 6 million plus notification, all of that within 5 seconds. So you can see how requirements can be changing all the time in a project. And our solution was to figure out what does not change. We figured that our operating principle does not change. And one of our operating principles at Duolingo here is to test it first. We're kind of obsessed with A/B testing. We can A/B test this project though, but I'll talk just in a bit how we test it. Our principle in this project is to not ship anything that we cannot test. And here's a few examples. When they came to us and asked if it is okay to send to a larger audience, we said yes, maybe, because we can probably test it. When they came to us and asked whether we can send notification with an icon, we said yeah, because we can test it. When they asked, is it okay to add the ability to send notification to different markets at different times? Sure, as long as we can test it. But is it okay to add 2 million users the day before, after basically we finalized the audience list? No, probably not, because we cannot test it. So after that, we established the timeline. Back in August, we know that we want to send to roughly 4 million users in less than 5 seconds. And we want to have the MVP ready by September 2023. And we know that we want to make sure that we cannot DDoS ourselves by the end of December 2023, so that enough time could be given so that new client changes could be rolled out to users. And by January 2024, we want to make sure that all testings are done, so that when Super Bowl really starts, we're ready because we have tested everything. Well, let me take you on the core of this presentation, which is the deep dive into the architecture of the system to send notifications. And to send 4 million notifications in 5 seconds, well, I still use 4 million. Maybe I should change it to 6, but you get the idea. It's a lot of challenge. And at Duolingo, we have an operating principle of embrace challenges. To summarize the challenges in this project, we have 3. The first one is speed. I'll call it how fast. Second one is scale, which is how big. Third one is timing, which is what time. The first challenge is speed, of course. So if you, well, I already told you that the speed is 800,000 notifications per second, roughly. And if you think of the population of Boston, last time I checked on Google, Boston has a population of 650,000 people. I think that was back in 2022. Now it's probably a little more, but to send notification to all these people at our rate, it'll take less than 1 second. It's just that fast. Second problem and challenge is scale. At Duolingo, we host a lot of our microservices on AWS. And unfortunately, that cost us money. Yeah, so, I mean, I wish it was free, but to build a system that sends notification really fast, you also have to make sure that it's scaled up to the point that it can do its job. And you also want to make sure that your backend is scaled up fast enough to do its job. And on top of that, you probably don't want to spend too much money on cloud infrastructures. And that is also a challenge at scale. And the third challenge here is timing. For those of you who are kind of into sports events, you'll know that sports events are kind of unpredictable because people get injured, or sometimes it goes faster or slower. Even the more predictable ones, like the soccer games, they're usually fixed 90 minutes, but they have added times. So it's also the same case with the Super Bowl. Super Bowls has timeouts and everything. And the problem with a ad campaign during Super Bowl is that you don't know exactly when your ad is going to air. And you see, our plan is to show the notification right after our ad airs. So we have to build a system that is on demand so that when some marketer presses a button, potentially a big red button, then our notification goes out. So we have to build such an on-demand system. And we want to make sure that maybe if two marketers press the same button at the same time, no duplicate messages go out. So that's the challenge of timing. To summarize, we have the following technical requirements to build this system. We want to send notification at the target rate. We want to get all the cloud resources we need just in time. And we want to ensure resiliency and idempotency. Well, I just explained idempotency here by the marketer example. I hope you all understand. But here's our system. It's basically an asynchronous system. We have a lot of our services on AWS. And I'll walk you through some of the use cases that we have and to basically show you how the system works. Let's assume that it's a few months before the Super Bowl. You want to upload a notification campaign. It starts out with an engineer creating a campaign with like a whole list of user ID. The server, after receiving the request, will acknowledge the request and then asynchronously fetching all the data from DynamoDB. After getting the data, they will put the parsed data into S3, logs the result into CloudWatch. And a few months has gone by, and maybe it's Super Bowl day already. You want to get ready because you want your backend infrastructure to be scaled up well enough to handle the incoming traffic as well as being able to send out the notification. So what happens then? The cloud operation admin will actually have to scale up the ASG, the automatic scaling group first. And then the engineers who's responsible, at the time it was me, would scale up the workers in the ECS console, just change a few numbers. The workers will then fetch data from S3, which we previously stored all the data in, and stored that data in memory. That data will be like a mapping from the user ID to the device IDs. After all that, the workers will log their complete status to CloudWatch. So maybe a few hours has gone by and someone was watching the ad and the ad shows up and someone presses the big red button. So what happens after that? The marketing admin hits the go button, and after that, the API server will actually send out 50 plus messages to the FIFO first in, first out SQS queue. The interim worker in between, after receiving those messages, they'll dispatch 10,000 plus SQS messages to the next queue. And finally, the last tier of notification workers will send notifications by calling the batch APNS and FCM's API. They are Apple and Google's notification API, if you're not aware. So after all that, after we're done making all the network requests, the workers will log their process time into CloudWatch so that we can analyze their performance. So let's come back to some of these technical requirements that we discussed earlier, because if the system doesn't answer all these questions, it's still not working, right? The first question is to understand, does it send notification at the target rate? Well, it's kind of hard for me to convince you, but some of you who are familiar with SQS might notice that SQS in itself has an in-flight message limit of 120,000 messages per second. And just to send 4 million notifications within 5 seconds would put us at 800,000 messages per second. And how does that happen? Because actually we simply use the technique of batching. We batched 500 iOS users together in one message, 250 for Android, and that put us under the limit. Second question we want to answer is, can we provision all the cloud resources we need in time? To solve this problem, we actually got in touch with a technical contact from AWS who helped us drafted an IEM, an infrastructure event management document, which included detailed steps like when and how you would need to scale up, as well as some of the more concrete steps, such as things like the cache and the cache connection limits and also dynamo limits that you have to consider to address in these kind of situations. I'll talk more about that later. And also, we also give the Superb Owl service its own dedicated ECS cluster. And I'll tell you just in a bit why we did that. Last question we want to answer is, can we ensure idempotency? To solve this problem, we actually cheated a little bit. We used a FIFO, first in, first out queue from AWS SQS service. Well, you see, the FIFO queue in itself, it deduplicates messages by message identifiers. So it also has a deduplication window of 5 minutes. So when multiple marketers press the same big red buttons, and it'll try to send the same messages through the queue will deduplicate the message for us. And we basically just hand off that work. And to keep in mind that the queue itself does have limited capacity for the FIFO queue. It has limited capacity of 300 requests per second. So if you're building a system like this for your own purpose, you also might want to use a cache or a table if you want to get past some of those limits. So let's get back to the system diagram graph. Does it send notification at the target rate? Yes. Can we provision all the cloud resources we need in time? Yeah. Does it ensure idempotency? Yeah. So some of you may say that we're probably done here. Well, I'm kind of inclined to say so, but actually not. So let's look at this timeline of where we are now. We basically are still at September 2023. It's when we built our MVP. And next subject is everyone's favorite subject, which is testing. How we tested it, as I just mentioned, at Duolingo, we love to test things by A/B testing. We are kind of obsessed with testing, A/B testing every single detail in the app. But this is honestly not a thing that we can A/B test because we don't want to leak our precious marketing creatives to our users. You don't want to show the dual spot on like something else because that'll ruin all the fun. So we have to come up with our own way of testing the service. And I'll walk you through a few examples of how we tested the service. First, we tested the throughput of the service. This is what I call how we test the MVP. At the beginning, we tested with not really notifications. We tested with what we call silent notifications. This is effectively an empty payload that we send to the client devices and see what happens. And it turns out, it seems that we ran into some bottlenecks. And the bottleneck we ran into was the thread count. Here you see, we actually built our service in Python. I know many of you might disagree. But if you are an expert in Python, you would know that when you build like multi-threaded programs in Python, you run into issues with global interpreter lock and all sorts of that things. And that's the issue that we ran into. So what could we do? We decreased the number of threads and continue with the test. Decrease it from 10 to 5 to 1, and the bottleneck seems to be gone. Then we decided to test with a larger audience, because at the beginning we tested with 500,000 users. Now we want to test with 3 million users. But then the bottleneck came back. As you can see, we decreased the number of threads, but to get the same performance, we have to have a lot of tasks. And it was really problematic to scale up to that many task count. So we decided to bin pack and put multiple processes within the same task. We experimented with a few setups and got to a point that we're okay with. The next thing we tested was the cloud resources. This is when we tested whether we can scale things up fast enough. The first thing we ran was pretty straightforward. We want to make sure that we can scale up the system to send the notification really fast. In this case, it's the Superb Owl service. It's actually relatively simple. You just go in, you change one number, and it scales up. It's just like magic. And then we want to scale up the backend. When we did that, go through a few more steps and understand what services we need to scale up. So we found those services, and we changed a few more numbers, and they scale up, just like your usual life. And then the third question we want to answer is, can we actually scale up both the Superb Owl service and the backend? And it turns out that we ran into some trouble. Here you see that when you have services in the same AWS ECS cluster, and when you try to scale up all of them, AWS is actually doing some maybe like bin packing problems and trying to figure out the optimal solution or some good solutions. Sorry. But in the reality, what we observed was that when we placed the Superb Owl service in the same cluster as the backend, it has to wait in some sort of a virtual queue. It has to wait for all the other backend services to scale up so that it can scale up, or vice versa. And that's not really the scenario we want to see happening, because we don't want to see our backend services waiting because our notification service is scaling up. And we don't want our notification service not being able to scale up because backend is trying to consume more resources. So that's when we gave it a dedicated ECS cluster so that it get rid of that queue. And last but not least, we want to ensure that we can scale up both of the backend and Superb Owl service in less than 3 hours so that we don't have to waste money to have these services running around like maybe days before the Super Bowl. And we did that, we tested, it works. Then we move on to test on real users. Well, I said that we don't want to leak the creatives of Duo's butt to our users. But I never said that we couldn't test on real users. So actually, we tried to test in plain sight using our new notification systems. In October, we tested on 1 million users using a Halloween-themed notification. In November, it was like a year-in-review themed notification. And in January, we tested on 4 million users with a welcome back from New Year message. And this is all us testing in plain sight without leaking the creative. And I want to mention that one of our internal tools called Zombie Mode really helped us in this process. Zombie Mode is essentially a mode that we created so that when we turn it on, the user's device will stop making the request to the backend for a certain amount of time until it tries to check that flag again. It helps us in the scenarios where backend cannot handle a surge in traffic and it needed time to recover. So thanks to that mode, we were actually more comfortable with testing with real users because we know that we wouldn't have extended periods of outages. One of our lessons learned here is to always actually send yourself a copy before sending it to the user, because you never know in what way your internal representation of the message could leak out to the user, and you never want that to happen. And last but not least, we tested with in mind our microservice architecture. Here are some of the things that we saw in that IEM, Infrastructure Event Management document. This is also the work of my colleague Milo mostly. The first thing that we considered was, is our Memcache Redis hitting connection limit, or can we use a proxy for some of the tables that we have? This is actually a real thing that we did. One of our services was having problems scaling up past 400-ish tasks because it was hitting the connection limit. Well, it wasn't really a priority to address, so people kind of put it off. Until this point, you really need to scale up. So what we did was we put a proxy behind the data store, and it actually can scale up to however many tasks you want. Problem solved. Second problem is, will our DynamoDB throttle? Well, DynamoDB claims to be like infinitely scalable, but some of you may know that it doesn't handle the spiky traffic really well, especially if you're provisioning your resources. So we consider, should we switch some of these tables to on-demand briefly, or should we like over-provision it to a point that it wouldn't throttle even with the spiking traffic? The last two are the things that we considered, but we actually never addressed, but I thought it would be relevant to mention here. One of the things that we considered was whether our retry policy was reasonable, because you can see we have so many microservices, and when one microservice called the other, it might retry 3 times, and the other call the third one 3 times, and it goes on forever, and it grows exponentially, and you don't want that to happen. And last but not least, we know that we are going to request a certain subset of our users. So maybe we could have cached some of the user data that we know that are going to be requested. But because of time limit of this project, we obviously didn't get into the detail of all that. But we got to a point where we were happy. So on the day of the Super Bowl, we have a pretty well-written playbook. We have engineers on the Zoom really carefully watching everything, scaling things up. And we have marketers potentially at their TV holding popcorns. That's how I imagine what they're doing. And we have a square go button. Some of you might ask, well, why isn't it round? I might explain it to you just a bit later. But when Super Bowl starts, everybody was watching, and we were watching for a different reason. And our marketers were waiting anxiously for the ad to show up. It kind of didn't show up for 20 minutes when it was supposed to. And when it finally did, 2 marketers click on that square button, and 1 message went out. All right. So the campaign results were actually wonderful. 99% of notifications were out in 5.7 seconds. 95% in 3.9 seconds. There was a Figma blog post written about it, and there's also a Wall Street Journal on our Super Bowl campaign. And I think someone on Twitter or X actually posted about our notification campaign as well. So it's time to move on and talk about what we learned and what we would have done differently in this project. Well, some of the mistakes we wish we had avoided relates back to the very fundamentals. We started out this project using Python, but it turns out it actually gave us a ton of performance bottleneck. We thought about using async Python. We tried it. It didn't really work with the toolings that we have. And actually, we didn't end up trying because at the time, our original notification stack was built in Python, and we don't want to reinvent all the technology, all the authentications, the connections that we established with the outside APIs. So we stopped there because we wouldn't have enough time to test. But actually, 1 month after the project, my manager came out to me and said, well, have you seen this Hacker Noon article from 2019 that says using Go to build a system that sends millions of notifications within a few seconds? I was like, that's interesting. I wish I had read that article. It could have given us a lot more inspiration and lessons. And that also uses Go, which is a completely different stack than what we used at Duolingo. But that could have helped us. The second thing that we wish we had improved was to optimize the memory. Well, I told you that at the end, we want to send 6 million plus notifications. And to pack all these 6 million plus device IDs and user IDs into the memory of a service, it was actually a lot. We ended up using 7 gigs of memory for each task. And you may remember that we have a lot of tasks, which means that it requires a lot of cloud cost and intervention. My colleague Milo works really hard on that, and we finally got it across. But if we have time, we would have optimized the memories and resource usage in general. And last but not least, we want to have better observability into the client behavior. Well, I told you earlier that our Android app used to have a problem when you send a notification to the app, it sends a request right back. That's effectively DDoSing ourselves. That's not a problem anymore, but we discovered new problems. Because we discovered that when someone clicks on the notification, it actually multiplies the number, I wouldn't say multiply, it triggers multiple requests to the backend. That number may be 10, 20, 50, and that's not good. Because even if like 5% of people click on that notification, and if that multiplier is 50, you're effectively making like 2 times our notification request back. And that's a lot of requests back to your backend in a short amount of time. So some of our lessons learned here are the following. The first one is to be open-minded about the design, but be more rigorous with testing. I wouldn't say our design was the best. It was really far from the best, honestly. But we went with one of the designs that we could iterate and test on. We know that testing will be the core of this project because as long as you can test it, you can make sure that the system works the way that it's intended. The second lesson learned is to always build the system with resilience and robustness. As we just mentioned, multiple marketers can press the same button at the same time. And you don't want duplicate message to go out to your users. And this is just one example of the things that you should take care of when you design a system like this. And the third thing is things can always go wrong, so accept it. I'm not really saying to do nothing about it. Actually, we took a rather active approach. We wrote a very detailed work handbook to tell engineers on that day what you should do on the exact time of the day. And also, it included backup plans. What if this A thing fails? What if this B thing fails? We even have a backup plan for like the whole notification not going out. What should we do then? Yeah, so I think what we are saying here is to face it with a more active attitude. And that is all of my presentation. Thank you all for listening, and I'll leave it up for Q&A. Thank you.
Hi, thank you for this amazing talk. I was curious about the number of instances in your ECS cluster, and if you guys try to vary that number or do some tests, or was it fixed at 5K as the limit for like the max amount for the ECS cluster?
Yeah, I think this is not my area of expertise, to be honest, but I think we did like experiment with different like instance sizes and everything. But as I mentioned, one of the things that we could have done better was to optimize memory. And at the end, we were kind of like bounded by memory because we tried to store all this information in memory. And so that led us to, in the decision of how we decide to select the instance types, which is ended up being like memory intensive instance types. And 5,000 is, I think it's just one of the numbers that we were comfortable with that makes sure that we can send out notification that fast. There could be a limit, but I think it's mostly handled by my colleague with some negotiation with AWS. Oh. Yeah. Oh, sorry.
Can we get another microphone?
Thank you for an excellent talk. I was wondering, so when we talk about workloads that need to scale very rapidly and are very occasional, my mind goes to serverless. So I'm curious, did you consider maybe using AWS Lambdas for some of the workloads instead of looking heavily into your container cluster? And what was the role of serverless in general?
Yeah, I think that was definitely one of the suggestions that was being made early on in the project. And I think someone suggested this to me and promised me, well, like even if it's Lambda, it can also like basically pre-spin up all the things under the hood, and you know you are gonna get all these resources. But at the time, like we just felt safer, like working with like all the existing like the containers and the ECS services. I think without seeing like the machines spin up for you, it still puts us like into the area of like we're gonna be like more concerned whether this is gonna work or not. But this is definitely valid because this is like basically like a one-shot operation, and you pay for what you do. So it would make sense in another scenario if we could test it to use like Lambda. Yeah. Mm. Oh.
No, got it. Okay, good. Thanks for your presentation. It was
Oh,
really
I'm sorry, I don't think I can hear you.
Hi. They said raise my voice. Thanks for the presentation. It was really great. Did your team worry about whether like FCM or APNS was gonna handle the load or freak out? Did you have to reach out to anyone to make sure that that didn't happen?
Yeah, that's a wonderful question. So basically, the question was about whether we're concerned we're going to get rate limited or throttled by FCM or APNS, right? So the answer is yes, we were concerned, but also at the very early stage of the project, we took initiative and we reached out. We asked some of our business people to reach out to the Google and Apple's reps to understand whether we are gonna get rate limited or not. And we only actually green flagged most of these after we knew that it's not gonna get rate limited. And yeah, basically that's the answer. Oh, yeah, please.
Hello, nice presentation. I'm curious about how you folks approach testing because I can imagine you talk a little bit about the cost, and then like how many times do you have to actually keep testing that and then actually multiplying the cost versus the times that you have to do testing. So I'm a little bit about how you approach the problems, testing times cost.
Yeah. I think our philosophy was that at least we want to minimize the risk. So the costs in tests are relatively smaller compared with the cost of like the system not working at all, first of all. But also, like, we try to leverage the system as much as we can when we test on real users. So as you can see, we tested on millions of real users in actual campaigns. And in those campaigns, we would have spent the money anyway. And that was like basically no cost for that kind of test. But on top of that, we did ran like multiple cloud tests basically to try to scale up the infrastructure only and not try to send anything. I think it's worth it to do maybe 3, 5, or even 10 times until you're at a point that you're comfortable with the system's ability to scale up, because it's actually our first Super Bowl campaign, and we don't want to mess it up. So we want to be as much risk averse as possible here. So cost is a little less of a factor if you consider we're already spending on the Super Bowl ad. Yeah.
As the Super Bowl is a very popular event, were there any concerns about capacity not being available when you wanted to scale up because this was such a high spike usage?
Mm-hmm. Yeah, absolutely. That's a very good question. I think this is definitely something that we talked with our AWS representative, and this is something we definitely raised early on, whether we're going to have enough memory, whether we're going to have enough like resource allocation for us. That's definitely something that you would have to discuss when you anticipate that your program is either like compute or memory intensive. I would say so. Yeah.
Hey, really good presentation. So for this project, yeah, I know you had to do a lot of scaling, but was there any strategy around like optimization for the service itself? And did you use any specific tools for that?
Yeah, actually, I think we are not like known for performance as a language learning company, as you may tell. But in this project, we mainly focused on like to get it to a point where we can send notification that fast. And the way that we tested it was actually just pretty simple. We logged some of the process times to CloudWatch, and we would process those logs afterwards and see how much time it takes to for like each functions or each steps to execute and figure out the bottlenecks and speed them up. I think there are definitely more performance like frameworks out there that we could leverage. But with the constraint of this project, we didn't go with all that. But definitely, it's like a good question and concern that, well, if we were to do this again, we definitely do it right. Yeah. Yeah. If there are no more questions, I can explain why we go with the square button now. Yeah. Yeah, this is all thanks to my colleague JP here's work. I asked him to initially make a big red button, make a round button, as you may imagine. But later we discovered, actually it might be a marketer who discovered that when you click on the corners of the button, which is like appears to be white, but it actually will trigger the same function as the square. You would call it, well, in video games term, like the hitbox is still a square. And that's not good. As much as we want to avoid like human errors, like we definitely want to avoid that, so we made it a square. So everybody knows what they're doing. And yeah, I think it's time. Thank you all for being here.